Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video, we're continuing the chapter on Stream I/O, and we're going to specifically look at the topic of exceptions. Now, exceptions have been mentioned previously, but we haven't gone into significant detail in them. The idea of exceptions is they are what happens when something goes wrong in a program. Now, they're mentioned here because when you start dealing with files, lots of things can go wrong, and we're now far enough along that we might want to write applications that deal with them appropriately. So, when you write programs, different languages have different ways of dealing with the situation where something goes wrong. In this case, probably the best example of this would be this line right here. When we create a new file input stream, there are a number of things that could go wrong. One of the most obvious of which is the fact that the file that we pass in might not exist. In fact, why don't we go ahead and run this program and let you see what happens in that situation. So, yeah, we'll do that. Whoops. Okay, so that's what it did if I run it correctly. One of the things about using a file chooser is that the file chooser makes it easy to do things correctly. But I'm going to change the name here. That file does not exist. And now when I click open, yes, down here I get a file not found exception. And in this case, it crashed my program. In addition to that happening, it's also possible that maybe the file existed, but I didn't have permissions to read it. It's possible that on other lines, for example, I go to read from the file and I can't for some reason. If I were reading, instead of just reading straight bytes, if I were supposed to be reading some format, I might get that the value that I read wasn't, for example, a number or whatnot. So when you start dealing with I/O, there are lots of different things that can go wrong. In some languages, the way that the program tells you that is it just returns some other value. So for example, in C, when you open a file, you would get back null if it couldn't open the file. The problem with that is that in some ways it's easy to ignore. It doesn't crash your program right there. It actually wouldn't crash the program until down here when we tried to use the null. And so Scala uses an alternate approach, which is used in Java and quite a few other languages, of using exceptions to indicate errors. You could also say that Scala uses exceptions to indicate exceptional situations. So when we have code that can throw exceptions and we want to handle it properly, we use the try-catch construct. So I have a number of lines here, all of the ones that deal with files, so basically those 4 lines right there. There's the possibility they could do things wrong. So I want to say that I'm going to try to do these things, and we'll see how this works. And then I'm going to catch certain exceptions. The format for catching in Scala is to basically give it a partial function of cases. We know that one of the exceptions that we can get here is a file not found exception. And so I will print the stack trace, Control-Shift-O to import the file not found exception. I still have one error here, and that is the fact that buff was declared up in this scope and not down here. So while technically this isn't going to potentially throw these I/O errors, it's actually going to be convenient for us to put it up inside of there. Control-Shift-F to reformat the code so we can indent things properly. So now let's redo the situation where I run this and I have it printing out. Cancel. Let's not print the whole stack trace. That is a very helpful thing to do. Maybe I should comment that. Instead, let's just print line Actually, let's do a dialog and throw up something. We want Scala swing dialog dot show message. The parent will be null. The message will be file not found, and the title will be error. Message type error top 1 and no icon. And then I can also have it so it prints the stack trace, because this will be interacting through the GUI, but it will also print things out. Once again, as a programmer, often printing the stack trace is helpful to you. I don't think I have a file called foo.txt, and there we go. Now I get a file not found as it pops up as dialog. It also happens to print out the stack trace, which as a developer might help me to see what's going on. Now, there can be other cases, so maybe there are some other exceptions. So let's say something else went wrong while we were reading. There's also an I/O exception. And let's go ahead and respond in a similar way, but instead of error while reading the file, because that's where that would likely occur. So we can have as many cases inside of here as we want in the catch for the exceptions that could occur inside of this. Now, while this this isn't the ideal way of handling this, because there's one minor problem. It turns out, so in the case of if this exception is thrown, everything's fine and we're happy. But if this exception is thrown by the read line, then we have some problems. Okay? And the problem that we have in particular is the fact that when an exception is thrown, the execution jumps to the catch, skipping any code below here, jumps to the catch, looks for the case. If there is a case that can handle it, it will execute that case. If there is not a case that can handle it, it will jump out of this function and then go to possibly catch in the function that called it, and then above that, and above that, and above that. If it gets all the way up to the top, it crashes the program, which is what it did when we ran this initially. But if this throws the exception, it means I don't execute this line. And that's a problem because I did execute this line. So right now, the way this code is written, it's possible that we could have a situation where I open the file and then I don't close it. And for a lot of the programs you're writing right now, maybe that's not such a big problem. But you will eventually hit a situation, as you write larger and larger programs, where the number of files that you can have open starts to become a significant issue. And so we want to be more careful about this. We want to make sure that we close off things that we're not using anymore. So how could we go about doing that? Well, first thing is we need to kind of separate it out. So I'm actually going to create another try block inside of here. And I'm going to put my general I/O exception inside of this try block. Now, for this try block, we know that the file opened successfully. If the file had not opened successfully, we would have fallen down to here and we would have exited, and so I would have never gotten to this try block. So for this try block, I know that it opened properly. I don't know if it's going to read properly. We still have the problem, if it throws the exception on the read, it will skip the close and jump down to here. And that is why the try-catch has another possible clause that we can add called the finally. Okay. So try-catch finally, what the finally does is this is code that is going to happen no matter what. So whether we have an exception or no exception, either way, this is going to occur. And in fact, the way that this is written right now, I could move that down to there because buff is declared up in here. Though if I want the exception, let's undo that. If the exception occurs, I probably don't want to try to print out the buffer converted to a string. So here we had to nest our two tries. We've shown how you can have a catch clause and you can put multiple cases inside of it. The use of a finally. The way that finally works is finally always happens, whether or not an exception is thrown. You'll note that our code got a lot longer. This was a fairly simple little example that we did previously of just reading in a file and printing it out. And indeed, handling errors properly does generally make the length of your code grow. One other thing to note is that, like almost every other thing in Scala, try is an expression, meaning that try has a value. Now in this case, I'm not using the value of try, but I could. Okay? I could make it so that I could say, some value, I could say val a equals, and then have a try block sitting right there, and that try could have a catch and a finally. So maybe I wanted to make it so that the try block here, I want to return the string of what was read, and if it can't open it properly, it will return the empty string or an error message or whatever. So I could play with that. Something to note, mainly because I've seen people mess this up, and it's a hard thing to diagnose. When you use try as an expression, the Scala type inference is going to try to find the type that works across all possibilities. So you kind of need the same type for the end of the try, the same type for the last thing in your catch, and that because those are the options for the things that are going to be returned. So I've seen situations where someone will have one case that doesn't return the right type. It winds up returning unit or something like that, and it will alter the type inference and they don't get what they want. So that's something that you have to look at closely. So that's your brief introduction to try-catch finally. And we're going to come back in the next video and we're going to talk about something called the lone pattern, which is a way to kind of simplify this code a little bit, in some ways reduce some of the boilerplate, because if you're doing a lot of file stuff, I don't want to have to do this whole bunch of code with the two nested tries and whatnot over and over and over again. So there's a way to simplify this and make it so it's a little bit easier to work with, so you don't have to duplicate as much code. And we'll see that in the next video.